Welcome, everybody. Let's say thank you to our sponsors and welcome to this session where we talk about bill of materials and the new feature for SQL Server graph databases, the shortest path. Who am I? My name is Andrea, last name is Martorana Tusa, I'm from Italy. MVP for data platform, and I'm leading a BI team for a company inside the Wirt group. We are based in Bolzano in Italy. Actually, I'm sad that we cannot meet in person. I've been twice in SQL in Wrocław for SQL Day. It's an amazing event, nice people. I enjoyed very much, and very sad that this year we cannot gather together. Anyway, let's go. Let's the knowledge spread out in different ways. So, what we're talking about today. Couple of words about graphs and SQL Server, graph databases in SQL Server. And I focus mainly on the new clause of the graph databases, the shortest path, and how to use for a real time, real case, real world example for tracking a bill of material in AX and Dynamics 365 databases. This is not an introduction to graph databases. I'm not talking about what a graph database is, features, everything about the graph databases. I have no time for doing it. I'm just giving you some few concepts that are what I need from my session for you to follow along the session. Just few points for helping you to follow along the session, but I want to focus on the way to approach and to solve a real problem. So, just what we need to know is that inside a graph database, we find out mainly two kind of objects, nodes and edges. Nodes and some related properties. Nodes are entities. When we talk about nodes, we are talking about products, customers, vendors, whatever you can think about an entity, something that is that is described and that describes something into your data model. And nodes are tables, and they are stored as physical tables into the database. Edges are relationships between the entities. So once you have two entities, people and roles, for instance, you have an entity because Adam is a business analyst. So the relationship between the people, the person, and the role is the edge, and is a relationship, and is this is quite important. All the relationships are directed. There's always a direction into the relationship, and therefore there is a start point and an end point. Edges as well, relationships as well, are stored as physical tables into the database. And this is the main difference between a relational database and a graph database. In a relational database, the relationships are based on joins, and they are logical connections. into a graph database, the relationships are physical tables into a database. So, just to give you an overview of the way a graph database is built up, you have people, you have degrees, you have companies, you have roles, all the balls are nodes because they are describing entities. All the lines between the balls, Mary Jones has a degree in statistics, and she comes from Contoso, and she is a program manager. All these lines are edges, are relationships. Graph databases were introduced in SQL Server 2017. This is the official picture from Microsoft website. You can find out the reference below. And it means that you have a database, and the database contains part of a graph into a standard database. You have both relational and graph objects that are stored as either nodes or edges. What is important to know, and what I want you to know, is that every time you create a node table, there is a node ID, internal node ID column created for every row. This column identifies a specific node into the database. And these node IDs are automatically generated. So it's automatically created by the database itself, but this is the key for creating relationships, for directing the relationships inside the edges, because when you create an edge, so I already said an edge, it's always directed and connect to nodes. So we have a start point and an end point. Every time an edge table is created, we have 3 internal columns created. The edge ID, the unique ID for the given edge into the database, and 2 columns, the from ID and the to ID. Here, it's stored the node ID, the starting point node ID, so the ID column we saw in the previous slide, the ID column from the node, and this is the starting node for the relationship, and this is the ending node for the relationship. So we are by default, all these columns are populated from the database, and this is essential in order to create a proper nodes. So this is how it works. Maybe the picture can help you understand better. So and is the person, it is the person table. In this person table, by default, by design, a node ID is created and every node has an ID. Then, when we have the edge is just a relationship between persons. In this case, it's friends of. So I have John, I have Mary, and I have Alice. And John is a friend of Mary, and Mary is friend of Alice, and so on. So all these kind of relationships are stored into these 3 columns. An edge table could not have other columns than the relation, the ID columns. You can add some properties to the edge. So the relationship started for instance, a start date for the relationship, or I don't know, a rating, whatever you want. But actually, an edge table could be simply done by the three essential columns: the ID, the edge ID, and the node from and node to ID, just for making the relationship and for giving a direction to the relationship. With the introduction of graph databases in SQL Server 2017, some language extensions were added. So there are new clauses and new functions added to the TSQL language with the introduction of the node of the graph databases. Of course, I can create a table as a node. I can create a table as an edge. I said that the edges are all stored as tables into database. So you can create both nodes and edges as tables into database. Just create as edge. Just create a table person as node. Then there are some constraints for maintain the data integrity inside the edge direction, and of course for keeping the relationship alive and valid inside the model. And the most important clause is the match. This is a new function suited for querying graph data. So when you are using a match, you are specifying a search condition. It's a part of a where clause, and it can be only used when there is a node, either a node or edge table. Example, just an example. So this is a common select from person. This is a relationship between persons who are friends of, and this is the way to retrieve the data using a graph database. So where no join, as you can see. There is no join because the join is into the edge table, and the edge table is the friend table. Match person one, and there is a direction. There is an arrow. So person one is friend of person two, starting from Alice. When I use match, remember that the relationship must have a direction. So if I go this way, node, edge, node, or the other way around, it's giving me a total different output, because I'm reading the data starting from a different point. One node to another node, one node to another node via an edge. The edge name must be inside the brackets. Just one row of code, easier to write than a relationship join. Okay. So that was the release of the graph features for SQL Server 2017. In SQL Server 2019, the most important feature was added, because honestly, it was not suitable for being used in production, a graph database in SQL Server 2017 without this because this is exactly this is absolutely the most important feature for a graph database. Shortest path. So what does it mean? It means basically that if you you are creating routes, you are browsing, navigating your data, crossing your data calculating routes. For instance, this is exactly why a graph database was created, and there are many examples of graph databases other than SQL Server that are native graph databases, Neo4j, for instance, some other graph databases. And this picture is coming from a book that has nothing to do with SQL Server. It's just talking about graph databases generally. So what we need, it's starting from in this case, the parcel set from a start point, crossing our data to find out the best route for delivering our parcel, for instance. Okay, so it's exactly the shortest path is exactly the way to calculate a route given a start and an end point. This is one of the most common application, and probably this is one of the most easier to understand of the easy to understand application. So what I need when I'm using a graph database is a traversal through my data. I give you a start point, find out the best route to the endpoint, or find out the level of the degrees of separation between one point and one other. So if I am in LinkedIn, this is exactly what happens, when you go on LinkedIn and you see you have a first level of relationship with somebody, and LinkedIn tells that you have second, third, fourth, and so on level of relationship with somebody else, because it's calculating the degrees of separation from you and another person based on all the people that are in the middle between you and the final person. Maybe you are looking for somebody in LinkedIn, and it is 3 degrees of separation from, he is 3 degrees of separation from you. Depending on the way the graph database can match you with the person you are looking for in LinkedIn. So from SQL Server 2019, we have this shortest path, and this is a function that gives you the shortest path between these two given nodes entities. Can find a single source shortest path, or can find the shortest path from multiple source nodes to multiple target nodes. There are some, let's say, limitations, restrictions. The function can only be used inside the match clause. So it's just a matter of syntax. There are some new terms, some new clauses that are introduced, and we just need to know. I don't pretend anybody to understand. I mean, I'm not trying to learn. It's just syntax. I know that if I want to get an output, I have to write down the syntax following the rules, and so open the doc online and look how to write your script. There are some clauses new that are shortest path, for path, arbitrary lang pattern. We will see how they work in our query. Last node, the node which appears last in the path. So you are traversing a path, and this is the last node of your path. And the order of the data into the output. For working, the shortest path needs aggregated functions. So what we need to use into our query are some aggregate functions. These are common functions. They have nothing to do directly with graph databases, with the shortest path. We know them: string egg, last value, sum, count, whatever you want, but you need to use some aggregations for because as you can see, the output is just given on one row. So we need an aggregation for putting the data together. So just an example: shortest path between two people. So I'm starting from Jacob, and I want to know the shortest path between Jacob and Alice. How many people are between Jacob and Alice? And this is the syntax that I have to use inside my query. String egg. So I'm aggregating the name of the people together with an arrow, just to give the sense of the direction of the relationship. Within group, this is specific for shortest path within group and the graph path. All these clauses are specific for the shortest path. Last value, it's an aggregation function. And for path, this is again a clause that I have to add to my query. So person one is friend of for path, where match, I'm using the match, shortest path between node, person one is a node, friends of is an edge, is the relationship between the person, and is directed from person one to person two. And this is the arbitrary length pattern. Node, edge, node. And this is the output, for instance. So I have, no, in this case it's different from the example before, because I'm looking for shortest path from a given node to all the other nodes in the graph. So Jacob is directly related to Mary, but between Jacob and Alice there is Mary in the middle, and Jacob is let's say friend of John through Mary, Alice. So there is a 3-4 level relationship between these two persons. Here I have the output on one row, and this is why we are using the string egg function, because we need to have all the names in just one row. And this is the arbitrary length pattern. In this case, I'm repeating the pattern one time. In some other cases, we are repeating, pattern some other many times. Okay. In this case, we want to know the degrees of distance from Jacob to Alice, but also we want to know so we are using a count. We want to know the number of levels between these two persons, Jacob and Alice, and there are 2 degrees of separation, the number of the levels traversed. Okay. Let me show you some examples for the shortest path. So I want to give you just a couple of examples. Okay, I've lost my connection. Nice. Sorry, I've lost my connection to the virtual machine. Okay, so okay, sorry. I have to mention the okay. I have to introduce the BOM topic before, and can you hear me? Can you hear me? Because I think I have some connection issues. Can you hear me? Can somebody tell me that you are hearing? You are listening?
Yes, I can hear you.
Okay, thanks. Okay, I think the connection was lost. Can you hear me again?
Yes, we can hear you, and
Okay,
yeah,
sorry.
we lost you for a
Yes,
second.
yes, I know. I'm sorry for it. Let me go again, and I'm sorry for it. Okay, so I just wanted to talk about the use of a shortest path for the bill of materials calculation. This is coming from Microsoft examples, and they are based on Adventure Works. So you can easily find out them. I give you the reference. So you can find out and replicate the examples if you want. So a BOM, bill of materials, of course, is made of some components. So if we use the standard Adventure Works company, which produces cycles, you have the final product as a cycle, and then you have some components, wheels, chains, brakes, tires, whatever you can think about. And so you can query your data. You can recreate the bill of material for a product just using a graph database syntax. In this case, we are looking for all the assemblies where a given product is used. So you are starting from product 2, bearing ball, and using the shortest path, you are retrieving all the items where the bearing ball is used. Just think about a multi-level BOM, a bicycle where you have wheels, where you have frames, you have rims, tires, colors, blah, blah, blah. How to query this data structure using shortest path. And this is what Microsoft gave us as an example. If you go here on channel 9, in channel 9 there's this short video where they are explaining exactly the example from the Adventure Works. So you can find out some text and also some data to download, the examples to download. So if you on the internet look for channel 9 shortest path, you land into this video. This video Microsoft gave some examples for using AdventureWorks, translating AdventureWorks into a graph database and for using shortest path. So these examples are coming from Microsoft, but I also have some examples on my own. If you want to replicate, download the scripts. The scripts are standard, and you can create your node table. And as you can see here, the syntax, you are telling, okay, use create this table as a node, insert some data into, and then create an age. And this table is created as an age. And then this is the most complex part, because when you have to create an example, actually you have to force the relationships, the directions. So in this case, in this example, they are pulling out the data from the node, the ID values for creating the relationships. But what you can see here, if I query this table product, you see here we have the ID column, and it's created by default, by design, by the system, by the database, with all the ID values that are used into the edge for building the relationship. Is part of the age is made by a single column, actually, but would have been without any column, and it's made of the edge ID, internal ID needed from the table, and from the two IDs coming from the node direction. So product, don't know, product 1 to product 2. And if you look here into AdventureWorks, because this is SQL Server 2019, into the tables, we have this, we have this graph tables folder where all the graph tables are stored. So anytime you create a graph table, your table is stored here inside as either node or edge, and it's stored inside the graph tables folder. Okay, so let's query the AdventureWorks standard database using shortest path, match shortest path. In this case, the product is product number 2, a bearing ball. And we want to know all the assemblies that are using a bearing ball. And here, as you can see, I have the full path for any object. Sorry. I have the full path for any object that is it's using a bearing ball as a part of its assembly. Okay, so I have starting from a bearing ball, I have some other products. Okay, and using the shortest path, I can perform some other kind of investigations. In this case, we want to find out the products that are up to 3 levels away from the bearing ball. So always starting from a bearing ball, just limit up to the level number 3. So in this case, this option, it's into brackets and it's from 1 to 3. In the previous example, it was just a simple plus. So I can force up to the number of levels, the iterations, the number of iterations I want to perform into my BOM. And I can find the shortest path between 2 given nodes, start node and end node. So I'm starting from node, from product number 2, and I want to go to product number 768. So what is the shortest path between these 2 products? This is the output. So I have a bearing ball, and then I have a bottom bracket, and then I have a bicycle. I guess this one is a bicycle's name. Okay. Let me get back to my slides, because now we are talking about how to do it in Dynamics 365. Because my problem was that we are working with the data coming from AX, Dynamics AX, or Dynamics 365. And some of our customers are asking us to recreate a BOM. So starting from, usually from a finished product, they want to know the list of all the ingredients inside that are making up this finished product. In Dynamics, we have semi-finished products, we have mixtures, we have ingredients, and we have raw materials. Into Dynamics, a BOM is described by the following information: a BOM ID, a BOM name, the BOM line that describes the components and the ingredients, and the BOM version, because a BOM could have some version, a BOM could have some validation period, start date, end date, this kind of stuff. If you go on Dynamics, so this is our demo Dynamics. This is the Dynamics we use for demo. It's based on Contoso data, so the data is quite poor and low quality, but just to give you the idea. So here, if I go on product information management and I go on released products, for instance, all right, this is the list. This is a list of products. And I can either start from the BOM or start from the product. So if I start from the BOM, from the product, sorry, let's go for this one. If I select this product, and if I go on engineer, you see here I have a section called BOM. I can see the BOM versions, the active BOM version for this product, and the BOM design. So I can see in which BOM this product is used. But if I go the other way around, come on, start new session. If I go on product information management, bill of materials. I have the list of all my bill of materials. So if I select one that I know that has some data inside, or let's see, one simple one before. This one, I have no clue what's inside. This product, this bomb, it's made of this product, just one product. But if I go on this one, come on. Okay, so this bomb is made up of some other products. M2, 3, 4, and D2, and blah, blah, blah. And if I go on Designer, I can have the structure of the bomb. So here, as you can see, this bomb has a tree structure, and there are some different levels. Level 1, and level 2. So this bomb has here I can design the tree for my bomb, and this bomb is made of different products on different levels. Of course, in the real world, the examples are quite more complex and more structured. These are Contoso demo data, so nothing fancy. One thing that I know that exists, but I never watched used. It's this routing. Actually, I think it's a shame because the routing. Let me show the routing here. The routing into Dynamics, it's quite interesting, but none of our customers is using it. But if you use routes, you have the order of the operations that are used to produce a product. And so you can have routing kind of what you need into your queries for building up the path, kind of a shortest path into, but none of our customers is using routes. I don't know if you have any other experience. Would be nice, would like to know, because I have no clue of route being used. So our customers are not using routes. It means that mainly I am building up a model based on two tables. Inside the Dynamics and the AX, they have the same structure. Inside the Dynamics, I'm basically using two tables: BOM version and BOM ID, where I have this one should be larger. 1 second, sorry. Where I have for every item ID, I have one single a one-to-one relationship between the BOM ID. This relationship, BOM ID and item ID in this table, is one-to-one. This one is the finished product material ID. Here, I have the list of all the items that are used inside the BOM. And so I have the list of the raw materials. So the challenge was how to iterate through this BOM table for looping and getting all the items involved into the creation of a BOM, and at what level. So let me show you what we did before in a standard SQL syntax. And this is actually what I have in place in many of my customers' systems, because just a few of them have upgraded to SQL Server 2019. Most of them are still on older releases of SQL Server. It means that we cannot use the shortest path. It means that we had to think about the way to loop through the data, matching these two tables I mentioned before, the BOM and the BOM ID. So if I have this product, this is the product code as a starting point. What we are doing is creating a temporary table. In this case, it's not used as a temporary for the sake of easiness. Then just create a temporary table, insert into this temporary table a first level of iteration that is the starting point. This is the starting point. For in this for this code in the BOM table, there are different products that different items, and then we can basically iterate through the BOM table and to loop all the item ID that are involved into the BOM structure. And the last point is a recursive CTE for recreating the BOM hierarchy. So more or less the output is this one, starting from the product L101. This is the first level of my BOM, and I'm inserting this level with a single insert, and then loop into the BOM table, getting both the items, the related, and the level of iteration of my products. So I can recreate kind of tree inside my data structure, and this is the output is a reporting services report with this structure. Sorry. So let me see if I can change just to see what happens. If I change the product ID, should give me another BOM. Okay. Okay, it's not working. I have to check why, but you get the idea. And the final step was to recreate this looping, showing how easy is when you have the correct structure, when you have the correct data structured into nodes and edges, how easy is to use the same the shortest path for doing exactly the same thing. So here I'm creating into the Contoso database some example data, a node, and I need two tables basically: the both item, the list of products, and the path between the products. This is an age, and this is a node. Then, of course, I had to recreate to force the construction of some data into the edge, because there was no data, using the node ID from and the node to. Remember to insert into the node ID from and to, and then I can query my I can perform the same query we saw before using a shortest path. It means give me all the assemblies that require this item into their BOM. And this is the list of my products: speaker, driver, and mini speaker. Then show me the bill of material for this product. Sorry. So this is the full bill of material, starting from this product: speaker damping foam, then cabinet, then mid-range speaker, then speaker pro kit. Or find all the products which are up to 2 levels away from the speaker damping foam, blah, blah, blah. So in this case, my query, these are the products 2 steps away from the given product and the different levels. Or shortest path between 2 given nodes. What is the shortest path between the P2 and D1 products? And this is the just this one. And this is the shortest path. Okay. I am 2 minutes late, but my presentation it's over. So thank you again to our sponsors. And if there is any,
Andrea,
yes,
we have one Q&A question. Ah, yes, second one also.
Okay, so let's maybe okay, so I can show the questions. Multiple ages allowed between the same node. Multiple ages. Yes. In the same direction, multi-graph. Yes. So starting from the same node, you can get all the. So if you want, maybe it's simpler to understand if you talk about a person. So if I am Andrea, you can find out all my friends, starting from a given person, Andrea. So I can retrieve all the relationships between me using and all the other people using the edge relationship. Second question: can edges? Oh, thank you. Have weights to create weighted graph. So what you can do into an edge is giving a property. As I showed you, maybe, so an edge can have a property. Maybe I hope this is what you meant. So if you go on, okay, the virtual machine is not working anymore. But for an edge, you can define a property. So you can give a rank, for instance, so you can give a value. So yes, starting from that value, you can create weighted graph. Can shortest path be calculated for such graphs? Never tried it, but I think so, because it's if you put the property of the edge into the where condition, I guess you could. So you have to work on the properties of the edge, and then it's just where. So if you put some conditions into the where clause, I guess you can filter out by that condition. Okay, can you tell something about the performance of graph tables? Graph tables are way faster than relational tables because graph tables are stored into the database. So they are physically stored into the database. The relationship is stored into the database. It means that the data is physically stored, and if you have, of course, good hardware, then the performance is way better, and especially because you can write simpler scripts. Okay. Seems no other questions. Okay, thank you everybody for joining. I hope you enjoyed. And if you want to reach me out, maybe just one, I want to share to you my contacts. I'm always happy to be contacted. It's as we cannot do it in person, but here there are my contacts, so feel free to contact me. You are very welcome. Thank you, everybody.